For 2 years, every AI company bet everything on one idea: bigger models win. OpenAI, Google, Meta, they all went bigger. Massive systems with trillions of parameters trained on incredible amounts of data. Then the industry discovered something shocking. The winners aren't the biggest models anymore. They are the smart, cheap ones. And this change is rewriting the entire AI playbook. Think of it like the 1970s auto industry. Everyone built massive gas-guzzling engines because size meant power. Then the oil crisis hit and suddenly the efficient ones won. That's what's happening now. The chase for trillion-parameter models is hitting a wall: deployment costs, latency, real-world constraints. Meanwhile, smaller optimized systems are crushing benchmarks at a fraction of the expense. Companies like Anthropic, Mistral, and even OpenAI itself are now pouring resources into smarter, smaller models. It's not just cost savings. These efficient systems run on phones, on device, without constant cloud connections. More private, more responsive, faster to deploy. The numbers tell it. Training state-of-the-art models cost billions 2 years ago. Today, efficient systems trained on billions of tokens, not trillions, are matching or beating those massive models on real-world tasks. The change is real, it's accelerating. And it means the game everyone thought they were playing is already over. But wait, there's something nobody's talking about. For the past 3 years, the AI industry operated on a single belief: scale is everything. Every breakthrough came from throwing more data, more compute, more parameters at the problem. OpenAI trained GPT-4 with hundreds of billions of parameters. Google built models with over 1 trillion. Meta's Llama models ballooned to 405 billion parameters. It made sense at the time. Bigger models did perform better on benchmarks. They could handle more complex tasks, understand nuance, generate more sophisticated responses. Every company with the resources joined the arms race. The billions flowed in. The model sizes kept growing. Data centers expanded to house the training runs. Electricity bills climbed into the tens of millions per training cycle. But somewhere along the way, something shifted. It started subtle. Researchers noticed that efficiency improvements sometimes matched raw scale for performance. A smarter training approach could match a 10 times larger model. Clever architecture choices could beat brute force. Then companies started deploying these smaller models in the real world, and that's when reality hit hard. The trillion-parameter models were too slow for live applications, too expensive to run, too power-hungry for devices. They required constant internet connections, massive server farms, and infrastructure costs that made them economically unviable for most real-world use cases. Suddenly, the constraint wasn't raw capability, it was practicality. And that's when everything inverted. Understanding the efficiency revolution starts with a simple question: what if we stopped obsessing over raw parameter count and started optimizing for what actually matters? It turns out, bigger isn't better for every task. In fact, for most real-world applications, a 70 billion parameter model trained intelligently can outperform a 405 billion parameter model trained inefficiently. The difference is in how you train them. Better data curation, carefully selecting the highest quality training examples instead of just dumping everything into the system. Improved architectures that use compute more effectively. Novel training techniques that extract maximum knowledge from fewer tokens. It's like upgrading from brute force to strategy. This economic angle is staggering. Training a massive foundation model costs hundreds of millions of dollars, maybe over $1 billion for the largest ones. Running that model 24 hours a day across thousands of devices costs millions monthly in electricity alone. But a smaller, efficient model trained on smarter data, it can cost 10 to 100 times less to train and run. Deployment is instant. It fits on a phone, on a laptop, on edge devices. No cloud dependency, lower latency, better privacy. Suddenly, smaller AI becomes not just technically possible, but economically rational. Companies that can't afford to train trillion-parameter models, that's most companies, can now build production-grade systems. The barrier to entry collapsed, and that's where things get complicated. Examples are already happening. DeepSeek, a Chinese AI company, released an open-source model called R1, 671 billion parameters. Sounds huge, right? But here's the kicker. It's trained on reasoning tokens rather than raw scale. It thinks through problems step by step instead of just brute-forcing answers. The result? It matches or beats models with triple the parameters on advanced reasoning tasks and costs a fraction as much to train and run. Then there's Mistral. They've built models like Mistral 7 billion, yes, 7 billion, that outperform much larger open-source competitors on standard benchmarks because of smarter training. Apple's doing the same thing with on-device AI features. Your iPhone now runs sophisticated language models locally because Apple invested in efficiency instead of raw power. Even Anthropic and OpenAI are jumping on this. Anthropic's been explicit about efficiency from the start. Claude 3.5 Haiku runs on phones and maintains quality at a fraction of what you'd expect from such a small model. OpenAI's releasing newer models that are faster and cheaper to run than their predecessors. The message is clear. The AI race isn't about who builds the biggest model anymore. It's about who builds the smartest one, who can extract maximum capability from minimum compute, who can get a system into users' hands without requiring a data center. And this is what nobody predicted. Let's put numbers to it. A 405 billion parameter Llama model trained on standard approaches needs 200 graphics processing units running 24/7 to serve 100 users. The electricity cost alone runs about $100,000 per month. Compare that to a 70 billion parameter model trained efficiently. It can serve 10,000 users on just 8 GPUs. That's a 25-fold improvement in efficiency per user served. On latency, it's even more dramatic. The massive models take 2-3 seconds to respond. The efficient ones, under 500 milliseconds. That's the difference between feeling instant and feeling laggy. On capability, the results surprised everyone. Independent benchmarks now show that well-optimized smaller models beat larger, sloppily trained competitors on reasoning, coding, and real-world problem-solving. A 13 billion parameter model with the right training beats a 70 billion parameter baseline on several metrics. It's not magic, it's just that throwing more parameters at a problem is the equivalent of hiring more people without better management. Eventually, you hit diminishing returns. Smart training beats dumb scale every single time. The economics flip too. You can fine-tune a small model for a specific task, customer support, code generation, content moderation, for thousands instead of millions of dollars. Deploy it on your own hardware, maintain full control, and pay nothing to a cloud vendor. Suddenly, every startup and mid-sized company has access to tools that only tech giants could afford a year ago. That's the real story here. The implications ripple across the entire AI ecosystem. First, it's a massive change in competitive power. NVIDIA's dominance was built on the assumption that everyone needed massive amounts of GPU compute. That assumption is cracking. As efficiency improves, you need fewer GPUs to do more work. Startups can compete with incumbents. A company that costs $100,000 to train and deploy a model versus one that costs $100 million is fundamentally more agile, more profitable, more able to pivot. The winners will be companies that nail efficiency, not raw scale. Second, it reshapes data privacy and control. Smaller models running on device mean your personal data never leaves your phone. Your conversations stay private. Your medical records stay local. This is a massive privacy win, and it also means companies don't have to bear the liability of holding millions of data samples in central servers. The infrastructure gets dramatically simpler. Third, it democratizes AI development. Right now, access to frontier AI is controlled by a handful of companies that can afford trillion-dollar training runs. In a world of efficient models, anyone with moderate compute resources can build competitive systems. The open-source AI community explodes. Regional players emerge. Localized models trained on local data become viable. The AI market fragments from winner-take-all, with 5 companies into thousands of companies solving specific problems efficiently. This is where the challenge gets real. So what do you actually watch for in this change? First, track how companies talk about their models. If they are still leading with parameter count, our new 700 billion parameter model, they are still playing the old game. If they are talking about efficiency metrics, tokens per second per GPU, inference cost per request, latency at scale, they're winning the new one. That's your signal that they understand what matters now. Second, watch the open source models carefully. Hugging Face's leaderboard now ranks models by efficiency as much as capability. The models that are getting adopted aren't always the biggest. They are the ones that balance quality, speed, and cost. The 7 billion parameter Mistral outcompetes hundreds of larger models on adoption because it runs on laptops and costs pennies to run. That's not an accident. Third, look at deployment announcements. When a company announces they are running AI features on phones, in browsers, on edge devices without cloud, that's the future. When they're still shipping everything through cloud APIs, they're betting on yesterday's model. Real competitive advantage now comes from running locally, staying fast, and owning your customer's experience end-to-end instead of renting cloud infrastructure from a vendor. This change isn't theoretical or years away. It's already in motion right now. Now here's where the real story starts. Here's what matters. The AI race just changed forever. For years, success meant having the most money and the most GPUs to chase raw scale. But that era is ending. The companies winning right now are the ones optimizing for the metrics that actually matter: speed, cost, quality per compute dollar, ability to deploy to real devices. Smaller, smarter systems are eating bigger, dumber ones for breakfast. This isn't just a tech story. It's an economic inflection point. If you work in tech, in AI, or in any industry being touched by AI, and that's increasingly everyone, this change affects your future. Startups suddenly have a path to compete. Smaller players can build specialized systems. Your personal data is more likely to stay private. The entire tech industry is about to become a lot more competitive and a lot more interesting. The moat that size created is disappearing. The speed of change here is remarkable. 6 months ago, everyone thought bigger was the only path forward. Today, it's already yesterday's strategy. This is moving fast, and it's picking winners and losers in real time. If you want to stay ahead, follow the efficiency metrics. Watch who's deploying to edge. See who's announcing smaller models that punch above their weight class. That's where the future is being built. Follow for daily AI news to stay on top of stories just like this one that are reshaping how technology works every single day.